Okay, so welcome to today's lecture. This lecture is about API, how to use this application programming interface to control your simulator. And today I'm going to talk about 3 software tools, including MSum, Paramex, and vSim. Please come closer, because we have small phones today. Come closer. MSum. In order to use MSum API, you have to use either Python or C++. And for Paramex, it's purely C or C++. For vSim, it has 3 kinds of APIs, including a COM interface, which allows you to use any kind of programming language. And it has a Python or C++ type car2x interface. Car2x means car to car or car to infrastructure. So it's about the communication between cars and other elements. This is another independent interface. The third one is called the driver model. It can only be used in C++. And this driver model allows you to completely override the driver's behaviors. So some drivers are allowed to equipped with these driver model, and other drivers can be the internal defined driver types. So in this way, you can change the behavior of some drivers. And I want to introduce this thing too, because it's an important tool for creating the photorealistic simulation movies, animations. Because in vSim, currently it already has 3D simulation, it has animation, but it's still not photorealistic. So if you use this tool, you will be able to create photorealistic simulation results. So today, the first one is the simplest. It's the MSum C++ API. Here are the steps that you can start. So you can go to the installation folder of MSum, then AAPI 6.0 and AAPI Visual. AAPI Visual means using Visual Studio to open it. Now, if you open a solution file called AAPI.sln using Visual Studio.net 2005 or above, you will see in the interface a Solution Explorer. Solution Explorer is an explorer of all the files in the solution. So it's like the Windows File Explorer. In this is the whole solution of the sample we just opened. And we can see some header files that are provided by MSum. And here is a source file called aapi.cxx. Typically we use extension as CPP to stand for C++ files, but they use CXX, but it doesn't matter. Now if you double click this file, you'll be able to see the source code. But at the same time, I recommend you to open this MSum API v6.pdf as your reference. So you have to look up in it very frequently. Let me show you this file. This is the PDF I just introduced. It's the Macro Simulator API manual. If you turn on these bookmarks, you'll be able to see different sections. And if you scroll down, you will see these are all the explanations of functions. So for example here, read the number of phases in the junction. And on the right is the function. It's a function. So it introduces the format of the function, parameters, and output. So this is a menu you have to frequently check. Now, here is a good figure, very good figure, describing how you use the API. Basically, for MSum API, you have several functions. For example, you have these functions called API load that will be loaded when you load your network. In other words, when you use MSum to load your network, this function will be executed once when it's loaded. Now, after MSum initialized, the simulation, this function will be called. So it's your function. MSUM will call your function. Then within the simulation, for each simulation step, two functions will be called. One called AAPI manage, the other one called AAPI post manage. AAPI manage will be called before MSUM performs all the models. And this post manage will be called after MSUM performs its simulation, every step. Now, if at the end of the simulation, this AAPI finish function will be called. Then when this network is unloaded, the last function will be called. So that's the way you integrate your program into MSUM. So you implement these functions, and MSUM will call your function.
So each time you write an API, you have to write these functions or call this in your own code, or that is something that ASM does automatically?
You have to implement these functions.
Those, okay.
In other words, if you implement this function, it will be called. If you don't implement this, MSUM, then you will not be called. So you are going to write a file, write a simple C++ file, in which you create these functions. All right. So do you all understand this? If yes, let me give you an example. So I recommend you to sit in front. Otherwise, these may be too small, these phones. So this is function I'm going to write. It's called AAPI manage. And this function has 4 inputs. So let's warm up. We remember when we do programming, we can write functions. Each function can have several parameters, input parameters. Now, in this figure, we are going to rewrite this function. Then for this function, if this function has several parameters, what does that mean? That means when MSUM calls this function, it will give you some inputs. It will give you some inputs. And that's why for this function, whenever this function is called, these 4 parameters will be given from MSUM. Alright? Then this function is called AAPI manage. If we go to the menu, we check this part, we will be able to see what it means. So here, it describes the time STA, time trans, and cycle. What these parameters mean. Basically, these are some parameters with the current time step. So when this function is executed, you will know the current time step because they are given to you as the parameters. All right. So I'm going to override to create a new AAPI manage function. And let me remind you, this function is executed at every simulation step here. So one step. So for every simulation step, this function will be executed once, and you will know the time step because they are the input of this function. Now, in the beginning, we declare a structure called INF, information of vehicle. And this INF vehicle is a structure that is defined by MSUM API. So these functions are implemented or declared in these header files. And in this C++ file, these header files are already included. That's why you can use these predefined structures. So we declare a structure called INFVEH, and we want to use this structure to store the vehicle information in the network. Now we declare a string, which is an array of characters called a string. This string has a length limit of 128 characters, 128 bytes. Now we declare an integer whose name is nSection, and we call this function provided by MSUM We can find it in the msum menu. This msum function is going to give you the total number of sections or rows in the current network. Okay. Now, for example, we know the number of sections is 10. Then we want to get all the IDs for each section. In another word, we know we have 10 sections, but their IDs are not necessarily from 0 to 9 or from 1 to 10. They may be, this one may be called 200, this one may be called 300. So we know we have 10 sections, number of sections, but we want to get their IDs. So we created a loop, a for loop, from 0 to this n section. Now we get another number, integer number, called section ID. And this section ID is given by another msum function. So we give it the sequence of this section, then we get the ID of the section. Alright, this step. I want you to ask questions to interrupt me, because today we have fewer students, fewer people. So if you don't understand any step, let me know. Otherwise, you are going to completely lose yourself. Now we already get a section ID. Then we use this function to get the number of vehicles in that section. This is section ID. This is another parameter, I forgot what it is. But in order to get these function names, you have to check the menu. Check the menu. Now we get the number of vehicles on that section, in that section. We create another loop to get each vehicle's ID. Each vehicle's information. So this function, if we use this function, we'll give the section ID and give the order of the vehicle. This can be from 0 to number of vehicles, for example 10. J can be from 0 to 9. So for each 0 to 9 vehicle, we can get its information. Remember this is the structure. Then this information will be stored in INFVEH. So we get the information of the vehicle, of each vehicle. Then we use the C++ function called sprintf to print these things, this quoted string into the predefined string. So we output the, for example, this is the vehicle ID. We can get as an element of the INFVEH. So INFVEH is a very long, very big structure, and it has a lot of elements. The ID is one element. Its current section is another element. Number of lanes is another element. The current lane is an element. Current position and current speed. So in this long, very long statement, we're just going to create a string using this format. And this %d means an input. So this statement means we are going to replace this %d using this IDVH, using this number. We are going to replace this using this number. %d means it's an integer. %f means it's a